Okay, hello everyone. This will be the um video for the transpose of an invertible matrix using the 3 by 3 matrix, given that we do have here a 2, 5, 7, 1, 3, 4, 3, 8, 6 matrix that we will begin to calculate with. So we'll begin to prove this one right now. That your formula given here, we do have two formulas denoted as the inverse of A, this is the transpose of inverse A, then the inverse of transpose A is actually equal to each other. So we'll begin to determine that later on. So it's been said that this will be the formula for the inverse, which will be there will be a 1 over the determinant A times the adjacent of A. So how to do it, by the way, we'll be going to, since we cannot solve our, excuse me, we cannot solve this then if you were not able to get first the inverse, I mean the determinant and the adjoint first. So now we'll begin to calculate the adjoint, the determinant for this following um A. So the determinant of A right now, since that will be the inverse, we'll begin to get the, since we're getting the inverse of A, so we'll begin to get here determinant on the adjoint so that we can calculate that later on. So we'll begin to get it for the first row only, since as long as if you will begin to calculate that second row and third row, it will be the same thing actually. It will still equate the same answer in the latter part. So let me go ahead and calculate only the first row for this one. So having this, we'll begin to get the cofactor for that one and to solve the determinant. So the cofactor of 2, since that will be the first row, so that will be 3, 4, 8, 6. So how to do it? It will become 2. Then, if you don't know how to do the determinants, kindly watch the video, first video for that one, because I will discuss that as well in detail. And this will be the I will begin to just run through this here then. So 3 times 6 minus 4 times 8. Here, that's how you will do it. Then will become 18. Then 4 times 8, it will become 32. And will become 2, then minus 18 minus 32 will become negative 14. So calculating them, negative 14 times 2, it will become negative 28. Then the next one will be 5, but will be the determinant of 5. It will become 1 times 6 minus 4 times 3. So it will become 5. Then 6 minus 12 will become 5. Negative 6 will become negative 30. Then, following the 7, that will become 1 times 8 minus 3 times 3. It will become 7. Then 8 minus 9 will become 7 negative 1. Then it will become negative 7. So right now, since we are supposed in the third 3 by 3 determinants, will be going to times that actually in this principle that we are having positive, negative, positive, the negative, positive, negative, positive, negative, positive. So this will be different. Just they will begin to multiply that in order for us to really get the value. So since we are using the first row, will become negative 28, then minus the negative 30, then um plus negative 7. If you will be going to calculate that one by since negative 28 minus 30, that will become, so for negative 28, let me just grab a calculator so that I will be going to determine that quickly. Okay. So, negative 28, it will be negative minus negative 30 will become plus 30. Then plus negative 7, it will become minus 7. So it will become negative 5. So your determinant right now will be negative 5 for this one. And we'll be going to get the adjoint for this because the adjoint will be different. You will need to get the transpose, the cofactor each and every each cases for that. So you have to watch that in the separate video because here I will just run through everything so that it will be quick. So for this one, in this invertible matrix, we will be going to just follow how I get the determinant, and how I get the adjoint so that you could be able to have it quick in terms of your calculation. We will not be going to base in the calculation platform, or the format that I've actually have in your determinants separately and for the adjoint separately. So for this one here, I'll be going to just directly um run through everything. It will become 3 times 6, then 4 times 8, then for 5, it will become 1 times 6 minus 4 times 3. Then for the 7, it will become 1 times 8 minus 3 times 3. Recalculating everything, it will become 3 times 6 is the same as earlier, 18. Then minus 32, then it will become negative 40. So that is the answer of that cofactor, since we're getting the cofactor. But here then we are not really um stating the step-by-step process for getting the adjoint, because that is actually based here. This is you just a run through, but in your examination it will be like this only for the invertible matrix. But for if I'm asking the adjoint, you have to follow the correct format of getting the adjoint of how was how I actually get that one in the video separately. So for this one here, let me just grab a copy for our let me just copy that here so that I could be able to manage to do it correctly. Now for the adjoint of the cofactor of your one, it will become, so for one, for the second row, it will become um 5 times 6 minus 7 times 8. Then for 3, it will become 2 times 6 minus 7 times 3. Then for 4, it will become 2 times 8 minus 5 times 3. So calculating it, it will become 30 minus 7 times 8, that is absolutely 56. Then you calculating 30 minus 56, that is negative 26. Then 2 times 6 will become 12, minus 7 times 3 will become 21. 12 minus 21, that equates to negative 9. Then for this one, it will become 16 minus 15 equal negative 1. So for this one right now, for going to the third row, it will become 3. The cofactor of 3, that is 5 times 4 minus 7 times 3. Then for the 8, the cofactor of 8, that is 2 times 4, then minus 7 times 1. And the cofactor of 6, that is absolutely 2 times 3 minus 5 times 1. So calculating it, it will become 20. 7 times 3, 21. It will become negative 1. Then 2 times 4 is 8. Then 7, it will become negative 1. 6, then it will become 5. It will become still negative 1. So calculate, since we are done with calculating, so you can just print out everything so that we can multiply that here, because we need to multiply that in this rule as well. since that's how it should be. So we'll be going to copy as is first before we will multiply that into the designated um sign that it must be. So -1, -1, and -1, and -1. So for this one right now, you will be going to multiply that into that one right now. Let me just grab a copy for that so that we can just copy and paste that here. For so afterwards you will be going to multiply that here then. So by multiplying the sign values for each of those negative times positive for 14, it will become still -14. Then -6 times negative, it will become +6. Negative times positive, -1 still. -26 times negative will become +26. -9 times positive equals -9. -1 times negative equals +1. -1 times positive equals -1. -1 times negative equals +1. -1 times negative will become -1. So right now this will be the result for the cofactor multiplied to the rule. But this is not the adjoint yet because the adjoint will be going to transpose that one. So you will be going to transpose this and that will be the adjoint. It will become -14, then 6. The first row will become the first column, -14, 6, -1, then 26, -9, then 1, then -1, 1, and -1. So this will be the adjoint of your particular matrix right now for the 257,134. This one here, 386, that will be the result for the adjoint. So since given that the formula of the first formula that we're basing is this one, and that will be, we could be able to let me just write it since the one that we are getting is A inverse. So the inverse is 1 over -5 because this is the determinant that was actually identified earlier. So we'll be going to also get the adjoint. So let me grab a copy for the adjoint and so that we could be able to um have it represented right there. So I'll be going through what's a basis right in I'll begin we'll begin to I put red there to simplify that it is the that is the specific what we call this one the adjoint. Now for this one right now we'll begin to multiply the adjoint. I'm so sorry. Let me just paste that right now. So the adjoint will become this. So let me just I'm so sorry I cannot be able to let me just resize that first. Okay. So there you have it. So I already have it resized. So the since that will be the result already, we'll begin to multiply that into the 1 over -5. So it will become -14, then negative of 5. So 26, -5, then -1, -5, then 6, -5, then -9, -5, then 1, -5, then -1, -5, and 1, -5, then -1, -5. So this will be the answer of your A inverse. That is the A inverse. But in our first formula, we'll begin to transpose the A inverse. So what will be going to happen? We'll be going to transpose this one so that we could be able to get the A inverse transpose. So the A inverse transpose, the first row will become this first column. So it will become -14 over -5. So 26 over -5, then -1 over -5, and then 6 over -5, and -9 over -5, then 1 over -5, and then -1 over -5, and 1 over -5 and -1 over -5. So this will be the answer of your A and transpose of the A inverse. So this will be the final answer that you're leaving here. So for that formula. But right now, what we'll be going to do, we'll be going to get this formula right now. So that is A transpose first. So we will be going to transpose the A first. So let me just get the A transpose first in here so that we could be able to get that later on, and then other position, yep, other place. Begin to transfer this, the location for this one. 257 will become the first column, then 134 second column, 386 will be the third column. So this will be the transpose of the matrix, but we'll be going to get the inverse for the right now. So let me just copy that as is so that this one, um, then I'll be going to bring that here so that we could be able to compare that easily later on with our other results. Since we'll begin to compare the A inverse, transpose of, the inverse of A transpose, then the transpose of A inverse. So we're going to, then that means we're going to compare them. So since the inverse of getting the inverse, we'll be going to get the determinant first. So getting the determinant of this one, it will become calculating the same thing, the determinant of this particular example right now, still the first row will become 2 times 3 times 6, that is minus 8 times 4. It will, I'm so sorry, that just automatically exit because of overuse as well. So let me just reopen that one so that we could be able to continue. For that, I apologize for that one. So let me just go ahead and continue where we actually stopped. So let me just grab the pen. So time, once again, is 3 times 6, then minus 8 times 4. So it will become 2. Then 3 times 6 times 3 is definitely 18. Then minus 8 times 4, that is 32. And then the result for that one will be 2. Then 18 minus 32 will be going to be the same, negative 14. So for that one, 2 times negative 14, that will become negative 28. So the next one will be the second row, first row, second column will be the one. The cofactor for one is 5 times 6 minus 8 times 7. And then 1 times 30 minus 8 times 7, that is definitely 56. Then 30 minus 56, that is definitely the answer for that one is negative 26. So you will be going to multiply that into 1, it will become negative 26. So the cofactor of 3 right now, we'll be going to identify that here. So 3 will be the cofactor, will be 5 times 6. Let me just write it because 5 times 6 and 8 times 7. 8 times 7, let me just check that one. No. We get a mistake. So since we are having the 3 already, it's not 5 times 6 already, since this will be the cofactor. So it will become 5 times 4 and minus 3 times 7. So that will become 3, then 5 times 4 equals 20, then 3 times 7 equals 21, then it will become 3, then negative 1, it will become negative 3. So by calculating that one, the same principles that we will be going to follow, that we will be going to observe the same, the same rule. So since we are getting the first row for that, so we'll be going to do it in here. So positive, then negative, positive. So it will become negative 28, then minus the negative 26, then plus the negative 3. So what will going to happen by calculating by calculating the negative 28, then minus to negative 26, that will become positive, then plus the negative 3, it will become -5, the same thing. So it is the same as what we do have earlier in the I no no no, it's not basis, it will be the determinant. So since we are done with the determinant, we'll be going to get the um cofactors, I mean the adjoint already. So the adjoint will be going to get the 3 by 3, the same thing that will be going to happen that what we did earlier. So since it will, you have to just base how we were able to get that in here so that it will be easy for you to manage everything. So it will become 3 times 6 minus um 8 times 4. For that, then the one it will become 5 times 6 minus 8 times 7. Then the 3, it will become 5 times 4 minus 3 times 7. So calculating this will become 18 minus 32. It will become 18 minus 30, so that is definitely the same thing, with a negative 14. Then 30 minus 8 times 7, that is the same thing, 56, that we do have earlier. Then 30 minus 56, that is the same thing that we've got, I mean, calculated earlier is negative 26. That's about, you can see that in the determinant itself. So it will become 20 and 21, and it will become -1. So that will be the cofactor result. So we'll be going to proceed to the second row. Let me just have a copy of our matrix so that I could be able to bring that down. So let me just paste that here so that we could have a basis already. So the next thing that we'll be going to um base here is for the 5. So for the 5 itself, the co excuse me, the cofactor of your 5, that is definitely for the 5 it is 1 times 6 minus 3 times 4. Then for 3, that is 2 times 6 and 3 times 7. Then for the 8, that is 2 times 4 minus 1 times 7. So calculating them will become 6 minus 12, it will become -6. And here 2 times 6, it will become 12 minus 3 times 7, 21. Calculating 12 minus 21, that is -9. And 8 will become -7, so it will become -1. So calculating right now the third row, it will become 7 is equals to 1 times 8 minus 3 times 3. Then for 4, that is um 2 times 8 minus 3 times 5. Then for 6, that is definitely 2 times 3 minus 1 times 5. So calculating them, it will become 8 minus 9, it will become -1. Then it will become 16 minus 15, it will become -1. Then it will become 6 minus 5, it will become -1. So by displaying that into the here it copy the results, -14, -26, -1, -6, -9, -1, then -1, -1, then -1. So this is the result for the cofactor, and we'll be going to multiply that into the into this one that we do have here. So let me just give a copy for this and have it in here pasted. And after that, let me just get that one so that we could be able to, let me just revise that so that we could be so that we do have the same outcome later. So just a moment. All right. So by multiplying them, let me just have a base the distance for that so we can identify. It will become negative 10 positive, it will -14. Negative times negative for 26 will become positive 26. Negative times positive -1. Negative times negative will become positive 6. Negative 9 times positive, it will become -9. Negative 1 times negative will become 1. Negative 1 times positive equal -1, -1 times positive, that is 1, -1 times positive equal -1. So this is the result for the we're able to multiply that already, but that's not the adjoint yet because we will begin to transpose this and that will be the adjoint. So the adjoint will be negative 14, 26, then negative 1 because it will become first column, and 6, negative 9, 1, then negative 1, 1, negative 1. So this will be the adjoint already right now. So let me just have a copy for this so that we could be able to calculate the inverse already. So, I'm sorry. For calculating the inverse, let me just go ahead and calculate that here above. So our formula earlier is this is A transpose, then we're getting the inverse for that transpose of A. So I'm sorry, it just exists. So for the transpose of A, we'll be going to get the formula um based on the transpose of A of inverse. So what will be going to happen since we are done with that? So let me grab a copy for the adjoint. Sorry. So this is the adjoint that we do have earlier. So let me just have a copy. So what we'll be going to do, we'll be going to base already and calculate that into the 1 over the determinant of A, then times to the adjoint. So our determinant is definitely negative 5, then times to our um, adjoint, which is this. So let me just go ahead and resize that. Resize. Okay, will be our result. Okay, let me just remove this. All right. No, 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 no. Okay. All right. Delete that. So for this one right now, what will going to happen since it will become negative 14 over negative 5. Distribute everything negative 5, negative 1, negative 5. So 26, negative 5, then negative 9, negative 5, then positive 1, negative 5, negative 1, negative 5, then 1, negative 5, then negative 1, negative 5. So this is your result for the transpose of A, getting the inverse of that. So we'll be going to compare these two if they equate the same result. So let me just grab the first result earlier so that we could be able to compare them both. So this is the result for your A inverse, which we able to transpose that earlier. So, no, 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 that's the correct one. That's the adjoint, sorry. Um, this is here. See, let me just copy and, see. All right. So, paste that here and then, um, right, this is your A inverse, and right now this is your um transpose of A, then we get the inverse. So comparing them, negative 4 into negative 5, 14, 6 and negative 5, negative 1 and negative 5, 26, negative 5, negative 9, negative 5, 1 and negative 5, negative 1 and negative 5, and 1 and negative 5, negative 1 and negative 5. So they are absolutely the same. So that means to say that our formula that we're able to use here is this definitely correct. So that's how you will begin to identify for this one right now. So make sure that you could be able to do like this as well in your examination. Thank you so much, and um, see you on the next